Hi there, this is the final video in a 4-part short series looking at a basic introduction to the Vicon Nexus 2 and Matlab interaction capabilities. So this one, today we're going to look at bringing in your analog data from Nexus into Matlab, and this is particularly useful because you can do a fair bit of processing in Matlab. So if you're interested in bringing in, say for example, ForcePlate or electromyography data, you can do that and bring it into Matlab. And today my example is going to be ForcePlate signals here. So you can see that I've got a running trial open, the same one I've had before in the previous 3 videos. And you can see there's an X, Y, and Z component graphed here to the ground reaction force from the left belt of this split belt instrumented treadmill. And so, if I stop that there, I'll come into Matlab, and again I've got my editor window open up top, and then the command window ready to run through the individual commands. And again I'll put the script into the description box below the video. So, this is a pretty challenging area to automate. I find it requires lots of input. So if you know the input and you have worked out what they are, you could write it simply with the known inputs. But for me, I'm trying to create a script that's like good and flexible for automation. So I suppose as well, like I've kept it kind of really open here in that the inputs that I need to bring in for certain statements, I haven't just listed through going into Nexus. I've actually automated the process, so I've taken them from Nexus as well and then input them in the next step. So you'll see what that means in a little while once we start progressing through the script. For now, we've got a couple of statements up top. So we've got the Vicon equals Vicon Nexus, as you've seen before, to establish the link between the two. Then we're getting the start frame and end frame, so the trial region of interest, because it's a crop trial. As you can see, if I zoom to the trial here, you can see it's cropped quite significantly there. And I'm also using the GetFrameRate command today, so that will give us our video frame rate, specifically not our analog frame rate. So if I run through these, and I'll just check what happens in the workspace. So we get the end frame of 1332 and a start frame of 26, and FS is 250, which I can confirm just by going in here and having a look that yes, my sampling frequency was 250 Hertz. Next thing I'm going to do is import the analog device names. So using this line of script here, sorry, there we go. And if I come into here, you can see I've got 2 devices. I've called them left and right, which represent the left and right belts. And so my device names should be stored here, right and left. And then what I've got is I'm saying, okay, these are the channels that are associated with these devices. This is about the only step I didn't purely automate, so I have added some input that I know from my understanding of how my ForcePlate data has been recorded. So I've got my 6 channels of interest here, so I've got FX, FY, FZ, MX, MY, MZ, and that's going to be consistent for me using ForcePlates regardless of which ForcePlate I use, so I'm happy to pre-define the channels there, so you can see that that's been stored in here too. And then we're going down to some pre-allocation here. Now, if you've used Matlab before, you're probably quite aware that Matlab will always prompt you to pre-allocate variables that change size on every iteration of a for loop, for example. So you can pre-allocate. You can skip this step and the code will work without it, so I don't have to run this step. But if you'd like to take a wee bit of reading in terms of pre-allocation, I'm sure it'll be something useful on the Matlab website that will tell you a little bit more about why you would want to pre-allocate. But essentially, if you've got quite a long script, pre-allocation will help it run faster as well, so that's something to keep in mind. So I've just pre-allocated, and now I'm coming down to the import device information section here. And like we looked at in video 3, I've introduced another for loop, And so for me, I'm going through my devices, so I have my left and my right force plate. Now you're probably wondering why I have it set up to bring in both force plates. I mean, right now I am, because this could be quite a versatile script here if it does that. If I was only looking at running data and I always use the left force plate, that might be an idea to say just do this to the left force plate. If you want to use this on a split belt treadmill, this code, you could do it for a walking trial where you might have one foot on each plate, for example. So I'm going to run through this, and it goes for each device. We're going to be getting the device ID from the name of the device. So that's the first thing that this line does here. And then we've got to get the device details, and in which case I've brought in only some of them. There's more available, so if you actually use the display command help for GetDeviceDetails, you'll see that you can have more outputs. Now I've chosen to suppress the first output, which I've used the tilde sign for there. And then I've got my device type, so that's like the type of device, whether it might be, for example, a ForcePlate or EMG. And then here I have DeviceRate, so obviously that's now we're talking about the analog sampling frequency there. And then we also have DeviceOutputID. So when I run through these, I'll show you what that looks like in a second. Here we go. So obviously, like we spoke of before, every time it goes through, it takes a new device. So we only have 2 devices. So the length of device names should be 2. So I chuck that down here and double check. Yes, it's 2. And so in the first case, I becomes 1. In the second case, I becomes 2. And so let's have a look now at our device IDs. And we've got 1 and 2 there. So that's coming correctly. So that's just an identification number to say, okay, this is associated with these device names. So we know our device name is, the first one is right and the second one is left. And so when it comes to device ID, this is going to be associated with the right plate and this with the left plate. Okay, and then the next thing that we're going to do is just double check. So our device type, we've got those out as force plates, which is correct. And then we've got device rate and device output ID, so rate, and we sampled at 1000, so we've got 1000 Hertz for each plate, and device output ID is here. And so your output ID of 1, 2, and 3 means that there's 3 potential output IDs for that device. So if we open up the left force plate here, and just close this for a second, you can see I've got 3. I've got force, moment, and center of pressure here. Alright, so returning now to our code. We're now at the point where we've gotten some information about the force plate. We need to now bring in that data. But unfortunately, we still need more information to make it automated. We're going to need the channel ID, and then we can start bringing in the data using the channel ID. So ultimately, the code that we're going to use, the line of code that we're going to use that's most important here, is this one in the middle. So if you have a look at this one here, this is all about bringing in the device channel. And if you have enough information prior, you can just use this get device channel without bringing in everything, all the information separately. So if you know this from Nexus, you can set this up quite easily. But for now, I'm going to assume that we don't, so that this can be a shared code and a bit more automated, like I said. But this little step here, so I'll just split these up so they're a bit easier to see. So this first one here, we're going to get the channel IDs. So we've got a for loop, and we're saying we're going to go device name 1, so we're going to go the left and the right plates using I as the stepper. And then we're also going to make sure with this if statement here is going to make sure that the actual device type is in fact a force plate. So if you have like multiple devices, I'm just using EMG as an example, but say you have a EMG signal coming in, you want to make sure that you've got that you're only doing this analysis to the ForcePlate, or you're only bringing in ForcePlate data. And so that line of text is just a checker to make sure that's okay. So again, another step of automation. And then for j equals 1 to the length of the channels, which we pre-written up here, we've defined 6 channels. So length of channels, you can always check that, is 6. And then the channel ID is going to be using the function getDeviceChannelID And so this is going to require the device ID. So let's say, for example, I equals 1 in this instance. So I is first going to equal 1, and j is going to equal 1. So this is a good way of like checking how your code's running and how it's going to work. So in this case, we've got a device ID. So our first device ID is 1, as we've seen earlier. And then this second term is the device output ID. So in the case that it's a force, it's going to be 1. In the case that it's a moment, it's going to be 2. And in the case it's a center of pressure, it's going to be 3. Now we're not interested in this third center of pressure, but it will be 1 or 2. So why I have written it like this is because if we go back to our channel list up here, essentially when we talk about these device output IDs, we'd have, for forces, we'd have 1, 1, 1, and then it would change to 2, 2, 2. So I tried to find a way to automate that, and so all I've done is CL means like a round up to the higher value. So say your value is 0.5, it will round up to 1. If your value is 0.2, it will also round up to 1. So it's a rounding up function here inbuilt into MATLAB. And so if you go, okay, let's take j and divide it by 3. So in the first instance, number 1, that's a force, right? So we want the answer to be 1. So it's just a automated way of working out that that is in fact 1. If j equals 5, then we know we've gone into moments. So if we still use this, it will realize that it's a moment and it will use the device output ID of 2. Now if you don't get this, don't worry about it. I mean, you can just set up a separate channel. You can also set out the device output ID up here. So we could say like, I'll just write it commented, but you could say device output ID equals, and then you could have 1, 1, 1, 2, 2, 2. And that should be fine as well. So you could also run through those and use it as a variable itself. So that's your call on that one. I just thought I'd give you this option because I think it's quite nice to automate it. And we also need to require the channel name. So for example, that would be fx if I was 1. Then the next step it's going to do, once it's got the channel ID, it can then, for that channel, because remember we're only doing one channel at a time within this J loop. So one channel at a time, we're going to go through here and we're going to extract the raw ForcePlate data. And obviously this is just a structure setup. We've used structures in videos 2 and 3, so it's a structure again. And we're getting the device channel. And using the device ID, again, we've got the device output ID and we've got the channel ID that we got from here. So you can see why we had to build it in this order here. And then all I've done here is a simple cropping of the trial. Basically, I've cropped the trial so that the start frame and end frame are the boundaries, because then we won't have all the space in the graph when we eventually plot it down here. So to wrap up, I'm going to run through this whole code and you'll see what happens. So I'm going to press play in the editor. And there I have my final plot of the cropped FZ data that I brought in. So this has just been quite a short introduction. I mean, you can go back and we'll look in here and you can see that the cropped data is available on the left plate. So this is the one that we plotted for an example today. So again, I'll put all the script in the description box below.